Hello everyone, thanks for listening to this presentation. My name is Tianhua and I'm a PhD student from the University of Queensland. Our work is accomplished by Shazia, Mata, and me all together. Today, I will provide a brief introduction and highlights of our work from the following aspects. From the background research, we can see that the problem of information silos has resulted in knowledge workers have to navigate through multiple information artifacts to complete their tasks, such as business process model and business rule repositories. And the knowledge workers' understanding of a task will be based on both of them. But when business process model and any related rules are presented separately, it can cause a lack of shared understanding, conflicts, and redundancies. To overcome such problem, prior studies have advocated integration of business rules into business process model, and various forms of integration have been proposed. However, there is limited knowledge on how knowledge workers make sense of various representations. Sensemaking is defined as a process of searching for representation and encoding data in that representation to answer task-specific questions. Later studies also expand the roles of sensemaking to individual cognitive processes, which are typically separate into two distinct phases. However, in the context of business process and business rule integration, current body of knowledge does not provide an adequate explanation of sensemaking behavior as knowledge workers navigate the two artifacts with various forms of representation integration. To explore this, we unpack the mechanism by which sensemaking behavior occurs when the form of integrated representation and task complexity changes. In this study, we consider the fundamental sensemaking constructs, and we use a number of behavior and performance measures through the use of eye tracking device in a controlled experiment. The participants in our study are university students who have fundamental knowledge in conceptual modeling, and the experiment data include of questionnaire, eye tracking log data, and task performance data. To capture eye movements, we use multiple areas of interest for analysis. Through multiple revisions, we created informationally equivalent models for all three integration approaches, and we also provide diversity in terms of constructs and coverage. In line with sensemaking foundations, we segment the experiment into two phases, which we further term them as understanding phase and answering phase. To capture sensemaking behavior in each phase, we use measurements related to fixation durations, frequencies, task performance data, measurements related to area of interest specific fixations, and transitions between them. Through a series of statistical analysis, we uncover the significant difference in scanning attention behavior between the three representations. By using mean fixation duration as a measure, the question-wise analysis indicates that there is some fluctuations in attention between the three groups. Then we further use heat maps to analyze how participants' gaze is distributed over the stimulus, as heat map can effectively reveal the focus of visual attention for multiple participants. As measured through mean fixation duration, we know that link representation requires less attention even when question complexity increases. This is observed for all participants in the initial question, and again as task complexity increases in the global questions, and it is the same for the best performers. We also know that diagrammatic group has the highest transition frequency between relevant area and question area. As for answering phase, our results indicate there is no significant difference between the three groups in terms of understanding accuracy, but we observe an increase in the percentage of questions answered correctly for the text and the link group. And we noticed that the understanding accuracy in diagrammatic group remains relatively stable. With the help of process diagrams, we also further investigate the answering phase with respect to the fixations and transitions to review the sense-making behaviors. Our result indicates that on global question in phase 2, compared with text and diagrammatic groups, the link group has the lowest mean fixation duration on the model area. For all group, compared to the understanding phase, we also observe reduced transitions between relevant and other area and between question and other area. And all questions in link group shows reduced transitions between rule and other area and between rule and relevant area. Our study result also show that even after understanding phase is complete, participants still engage in deep processing information in the answering phase. In this paper, by using sense-making lens, we investigate how user behavior occurs when the form of integrated representation, namely as business process models and business rules, and task complexity changes. Our study shows that link representation shows better task performance in terms of accuracy and efficiency, especially as task complexity increases. Additionally, our result also provides some evidence that as task complexity increases, diagrammatic representation requires the most effort. And our study is not without limitations, such as we only consider basic constructs in business process models, and we have mostly analyzed and present the result of performers who answer the question correctly. In our further work, we will continue review insights into sense-making behavior of other participants and the change in behavior over longer tasks with greater variability in task complexity. Thanks for your time, and we welcome all suggestions and questions. Thank you.